Good morning. In this session we will take down another problem based on torque on a current loop which is placed in a magnetic field. Now first we will see the question. A circular coil of 20 turns and radius 10 centimeter is placed in a uniform magnetic field. Of 0.1 Tesla. Normal to the plane of the coil. Normal to the plane of the coil. If the current in the coil is 5 ampere, what is the total torque on the coil? What is the total torque on the coil? Average force on each electron in the coil due to the magnetic field. Also given, the coil is made of copper wire. The coil is made of copper wire of cross-sectional area of cross-sectional area 10 raised to the power minus 5 meter square. Area 10 raised to the power minus 5 meter square. The free electron density in copper is given to be at 10 raised to the power 29 meter minus cube. 10 raised to the power 29 meter to the power minus 3. Okay, so now a circular coil of 20 turns and radius 10 centimeter is placed in a uniform magnetic field of 0.1 Tesla. First we will write down the given things. Given circular coil of number of turns N is equal to 20, and also radius of the coil 10 centimeter. Also the magnetic field B 0.1 Tesla. Also given the direction of the magnetic field and is normal to the plane of the coil. That means area vector and the magnetic field are in the same direction. Also we are given with current in the coil 5 amperes. What is the torque on the coil? Now first we will find out what is the torque on the coil. Torque on the coil, we have the equation as torque is equal to NIBA sin theta. Now here we are given with a rectangular coil and it carries some current, and what is the direction of magnetic field and the area vector? If this is the direction of area vector, that is the line which is perpendicular to the plane of the coil. Now given that the magnetic field is normal to the plane of the coil, that means it is exactly parallel to the area vector. B will be in the same direction. Therefore from this we can say that the angle between A and B is 0. This is the condition of minimum torque, where the torque is 0. We will make a note of it. The magnetic field is normal to the plane of the coil. Therefore the angle between A and B is 0. I can write theta is 0. Theta is 0. Therefore it is the case of minimum torque. When theta is 0, that exactly means that sin theta is 0. Therefore it is the case of minimum torque, or torque on the coil is 0. Torque is 0. No torque is acting. Now question number B. What is question number B? Average force on each electron in the coil due to magnetic field. Now average force on each electron in the coil due to magnetic field. First we will write down what is the equation for average force. Force acting on each electron is given by, we know it is EVDB. EVB, that is by definition. Here we have to calculate this V. V is the drift velocity, so you can take it with the suffix also. EVDB into sin 90. Sin 90 is 1, so force F is EVDB. E is the charge of electron and Vd is the drift velocity. So first we have to find out what is the drift velocity. To find drift velocity, Vd, to find drift velocity, Vd. So here Vd, so this is the drift velocity. We have to first find out what is Vd. We will take the equation, the current I is AN E into Vd, where N is the number density of electron. N is the number density of electron. So all these quantities are given. The given value of I is 5 ampere, and the area of the cross-sectional area of the coil is given, that is, the coil is made of copper wire of cross-sectional area 10 to the power minus 5 meter square is given. Therefore, it is 10 to the power minus 5, the cross-sectional area of the wire, into number density of electron is 10 raised to the power 29. 10 raised to the power 29 multiplied by, you know the value of E, that is 1.6 into 10 raised to the power minus 19. Into Vd. Therefore Vd you calculate, Vd will be equal to 5 divided by 10 raised to the power minus 5, that is cross-sectional area, into 10 raised to the power 29 into 1.6 into 10 raised to the power minus 90. So this comes to 5 divided by minus 5 so now you calculate the value. So how much you are getting? 5 divided by 10 to the power minus 5 divided by 10 to the power 29 divided by 1.6 10 to the power minus 19. That comes to 3.125. Multiplied by 10 raised to the power minus 5. Meter per second. Now next is find out what is the force. Force is equal to, therefore, EVdB. So E is 1.6 into 10 raised to the power minus 19 into 3.125 into 10 raised to the power minus 5 into B, that is 0.1 Tesla. Now what is the value of this? Just calculate. Five multiplied by 10 raised to the power minus 25 Newton. That is the force. Force is 5 multiplied by 10 to the power minus 25 Newton.